Part 3 of integration by parts. I'm going to familiarize you with the integration by parts formula. I find that this formula invites a sense of disorientation. So I want you to get comfortable with it. I want to give you an idea of the challenges you're going to bump up against and give you an idea of how to meet those challenges. So, first, the big picture thing I want you to know is that these will take up a lot of paper. These can be very long problems, so make sure you've got plenty of paper. And you want to write big, write legibly. You're going to be changing exponent signs. You're going to be distributing negative signs, so you really want to be able to see what you're doing. Okay, so let's look what we have here. You'll be given two functions that are multiplied together and be asked to find the integral of them. So just remember, it's always a good idea to remember what you're doing. What you're doing is you're going to be finding an area formula, an integral, so that you can use to find the area of a bounded area underneath a curvy line. Okay? So what do we mean by product of two functions? These are going to be two functions that don't play nicely together, that they don't blend together when they're multiplied to be nicely integrated. So for instance, you might have something like 3x cosine x. We don't have a rule to integrate those. We do have a rule to integrate something like 3 cosine x, but not 3x cosine x. Or it might be x ln x. They don't play nicely together. So we need the integration by parts formula. What's surprising about this is that you've got to choose which is v, dv, and which is u, and your choices are going to impact what goes on this side of the equation. And what happens on this side of the equation is that this term will often also become two functions multiplied together that don't play well together and therefore can't be integrated. So you're going to have to do the integration by parts formula again, just on this part. And that's where the problems can get really long. This part will never give you a hard time. It's if you get 3x cosine x right here, no problem, because you don't have to integrate it. This is where the problem begins to really blow up. Okay, so what's odd about this formula is that, look, you've got two integration signs, and you've got a dv here and a du, which means you've got two derivatives, two different derivatives, as well as integrals. And you're going to be going back and forth between integrals and derivatives. I mean, remember derivatives from like last semester? Here they are again. You may have forgotten about them. And we're going to talk about that. But what you're going to need is you're going to decide which of the functions is a u, then you're going to find its derivative. Then you're going to then the other function is going to be the dv, and to get v in this formula, you're going to have to find its integral. I get a little confused with that. This really helps me. This chart really helps me. So here's my integration by parts formula again. If I have u, I have to remember that I derivate to get my du. If I have dv, whatever my dv is, I've got to integrate to get my v. One thing that I was confused about a lot is the language of all of this, where they would talk about integrals, functions, and derivatives. And I thought there were three things going on. But that's not true. There isn't. There's just integrals and derivatives. Everything's a function. So this is what you've got. Here's the plus c, because, at the end you've got to add in a plus c. Okay, so back to this. Now, you're going to know your integrals, and you have to know your derivatives. And chances are at this point in calculus you're not fluent with those. You may never be fluent with those, but that's okay, because they're all like right here. Aren't you glad? The problem with this, though, is that this is cumbersome. Not everything you need is going to be right here. You may have to look up things in the book, but your book is definitely a resource. It's not my favorite resource to do these problems because it is so cumbersome. Another resource you have, of course, is the internet, which if you need the integral of a function, you can look it up. But I'm going to tell you that I don't think that's a great idea, because the last thing you want to do when you're doing these problems is be on the internet. As a matter of fact, I'm going to say when you're doing these problems, you should have your phone on airplane mode, because you don't want to be distracted while you're doing these. So what to do? I suggest that you create for yourself, or just download from my website or from the notes in this YouTube video, your own tables of integrals and derivatives, so that you understand, so you don't have to constantly be referring to the book. This Foldable pretty much has everything you need to get started doing integration by parts, and it also exists in this page form. So no strings attached, just download it. You'll see me using these a lot when I'm demonstrating problems, which I eventually will do. Okay, so the last thing I want to show you is the types of problems that you're going to be seeing. You're going to be seeing a few things. You're going to be seeing things that have an x or an x squared times a trig function. And that takes one kind of skill set to work out. Chances are what's going to happen with a lot of these is you're going to find the derivative of x. It's going to be a 1 or a 2, and you can multiply it by whatever the integral of this is, which is probably a trig formula. No problem. Sometimes, though, this will be an x squared. So you're going to have to do an integration by parts twice on this. And be prepared for that. The first time you see these problems, people are generally not having you do integration by parts numerous times, but this can get really long. Okay? Another type of problem you'll see is where both of these are trig formulas, like cosine x times sine x. And no matter how many times you find the derivative of either one of these, they're going to stay trig functions. And no matter how many times you find the integral of the v, it's going to stay a trig function. And you'll find yourself in this continuous loop that you can't get out of. And the big star to get out of that loop is going to be arithmetic. Okay? And so brush off your addition, subtraction, multiplication, and division skills, because arithmetic is going to get you out of this one. Okay, and then there's this other kind. It's really strange, and it's because there's only one function there, and it's not in our integral table. So how do we find the integral of it? Well, I call this the mathematician's number one superpower, and I will be doing an example that shows how to get yourself out of this jam. Okay, so that's it. Consider yourself introduced to the integration by parts formula.